Astronomy research has long been dominated by mysterious radio waves. Information about strange signals emanating from the galactic core has been made public by astronomers. Something strange that emits a powerful burst of energy 3 times per hour, unlike anything astronomers have ever seen, has been discovered by a team scouring radio waves in the universe. The strange object, which is spinning in space, produces a beam of radiation that crosses our line of sight and, for 1 minute out of every 20, is among the brightest radio emitters in the sky. Uncertainty surrounds the nature and source of the radio wave bursts. Another strange radio emission from the center of our galaxy has been found by researchers, but it hasn't yet been explained. Unusual radio signals can be produced by a variety of neutron stars, white dwarfs, and possibly black holes. A radio source that was recently described, however, does not appear to follow the patterns we have seen from other radio sources. In this video, we'll discuss some potential origin theories for this puzzling, never-before-seen radio signal. There have been a ton of strange radio signals discovered in the past several years, seemingly out of nowhere. This is as a result of numerous new radio astronomy projects being launched globally. Scientists have produced some amazing radio maps of the night sky, where we can see the night sky in all light wavelengths, thanks to the rising efforts in radio astronomy. One such fascinating project developed by researchers using cutting-edge radio astronomy techniques is the gleamoscope. What do we notice? So recently, scientists discovered a strange flashing radio signal that appears to last 30 to 60 seconds and is located roughly 4,000 light-years distant from us. One of the brightest objects in that radio frequency to date, it appears to do so every 18.18 minutes and exhibits patterns that are unrelated to those of any known celestial objects. Any astronomer who sees this phenomenon will find it to be extremely unsettling. The object was discovered by Tyrone O'Doherty, an honors student at Curtin University, using the Murchison Wide Field Array (MWA) telescope in remote Western Australia and a cutting-edge strategy he created. Yet, it also has certain similarities to specific kinds of objects, such as some kinds of pulsars or neutron stars. It continues to be a very peculiar object due to the actual display of frequencies and how they repeat in this radio broadcast, since no other object known to science has ever displayed these similar patterns. Theoretically, this object is currently located in our galaxy's backyard. It is only about 4,000 light-years from Earth, which is closer than many other nebulas, and this object does resemble a regular pulsar in some respects. It does pulse and emit extremely brilliant radio waves, but a pulsar differs fundamentally from it in that it does so much more quickly. A pulsar's single pulse may typically be detected in seconds or even milliseconds. In contrast, this unusual object appears to move extremely slowly. This radio signal has never before been observed to have a single pulse that lasts for up to 1 minute and 18.18 minutes. It is similar to a pulsar that appears to be moving extremely slowly, but the signals coming from the object also seem to be highly polarized, which is typically caused by magnetic fields that are enormously powerful and billions and trillions of times stronger than those found in our solar system or on Earth. Because of this, astronomers think a special magnetar rather than a typical neutron star is more likely to exist. The first explanation transients are astronomers' term for celestial objects that appear and disappear across the universe. ICRA Curtin astronomer and co-author Dr. Gemma Anderson said that when studying transients, you are observing the collapse of a massive star or the activity of its remnant material. Like supernovae, slow transients can appear over a few days and then vanish a few months later. Pulsars are neutron stars that flash on and off in fractions of a second or seconds and are examples of fast transients. For astronomers, it is really strange to discover something that turned for a minute. The unusual object was also smaller than the Sun, extremely dazzling, and released highly polarized radio waves, suggesting that it possessed a very powerful magnetic field. This brings us to the first hypothesis put forth by the scientists in their paper to account for this peculiar radio signal. In theory, this object could be the first magnetar or pulsar with an ultra-long period ever discovered. Although it doesn't spin very quickly, the strongly magnetic neutron star looks to produce a lot of energy. This pulsar naturally rotates once every 18.18 minutes for whatever reason, spewing incredibly rare, extremely slow emissions while nevertheless producing the same amount of power as a typical pulsar. Scientists have so far identified 71 of these pulses coming from this particular object, but they were brief and the object itself seems to have stopped sending signals for some reason. However, we still don't fully comprehend magnetars as of right now. About these strange, potent objects, there is much to be discovered. Even their development, evolution, and eventual fate are unknown to us. A magnetar is one of the more likely theories at the moment. It might merely be a magnetar that has undergone evolution or one that isn't as active as some of the other neutron stars. Additionally, the radio source's measurements match a hypothetical ultra-long period magnetar according to astrophysical theory. The existence of this kind of slowly rotating neutron star has been theorized. But no one expected to find one of them directly since scientists did not expecting them to be that light. The conversion of magnetic energy to radio waves by this magnetar appears to be much more efficient than anything previously observed. Also, interestingly, magnetars seem to be the potential answer to the fast radio bursts that have baffled astronomers before. In other words, at the present, magnetars may explain a lot of things in the world, or they may just be a form of patchwork explanation for a lot of things we don't understand in the universe. Second possibility, in any case, it's only one of the potential possibilities. The other one is also extremely fascinating and practical. This object might possibly be an extreme instance of a white dwarf with extraordinarily high magnetic fields, and because white dwarfs do not spin as quickly as neutron stars. It would explain why we're finding these specific fingerprints. In the case of a normal neutron star or magnetar, for example, we anticipate them to be a little more consistent, emitting a lot of radiation over a longer period of time. But for a white dwarf, especially if it has anything in its orbit, some of these emissions may be ephemeral, lasting for a few days, a few weeks, or maybe a few months. So, aside from the magnetar, which is the first option in this situation, the second possibility is that it's some kind of peculiar magnetic white dwarf that doesn't spin as quickly but emits just as intense emissions. Because the item was only active for about 2 months and hasn't really been active since, it's tough to know what it is until we see it do something else. The future? Astronomers are currently using the MWA to monitor the item to see if it turns back on. If it happens, there are telescopes all throughout the southern hemisphere and even in space that can gaze directly at it. Scientists intend to look for more of these odd things in the MWA's huge archives. More detections will inform astronomers if this was an unusual one-time occurrence or a massive new population that we hadn't observed previously. The telescope, according to MWA Director Professor Stephen Tingay, is a forerunner device for the Square Kilometre Array, a global attempt to build the world's biggest radio telescopes in Western Australia and South Africa. The fact that we have been able to gather and maintain all of the data produced by the MWA for over a decade at the Posse Research Supercomputing Center has been important in discovering this object and analyzing its specific attributes. It's fairly uncommon in astronomy to be able to search back over such a big dataset when you identify an item, he added. So, whatever this item is and whatever the scientists uncover in the next few years, it's a really interesting and unexpected discovery. This is so far the only object doing so, but because of these more powerful telescopes, we may uncover additional unique radio mysteries in the coming months. So make sure to subscribe to the channel because we're to come back in the future with more unusual discoveries like this, and share this with someone if you learned something about space today and remain insanely curious. What do you think might be the possible explanation for this mysterious radio signal? Let us know what you think in the comments section below.